So this lesson is going to be on controlling a servo with a thumbstick, which lets you do quite neat things. So this is an example of two servos controlled by a thumbstick, and on top of this is a little sort of Wi-Fi capable camera attached to a ESP32 board. So what this does is it actually, when it's powered, which is not in this example, but when it's powered, it can connect to a Wi-Fi network and you can log in to its particular IP address from your computer connected to that same Wi-Fi network, and you can have a look at what's going on through this camera. And in sort of future projects, you can take things like this and you can actually control them through sort of a web interface rather than using this joystick to control it. But using the joystick is a really good way to get a concept of how to actually control these servos and how to move this thing around. So we'll have a quick squiz at that. So you can see, all right, I've got a thumbstick and it controls both of my servos. And that lets me sort of move this little camera around and look at stuff. And the idea for this was that I would be able to have it set up near the 3D printers and I would be able to log into it remotely and just have a look at what they were doing, so that I can check on, if there's been any failures or if I'm close to running out of filament or sort of anything like that, without having to actually go physically to the class where the printers are. Right, so that's an example of the sort of stuff that this leads towards. So here is the schematic, and here is a little picture of it on the breadboard. Now I want to focus on the schematic first, because in previous lessons we've had a look at voltage dividers and how to read voltage dividers, and we're essentially doing the exact same thing with this joystick. We've got two voltage dividers, and if you actually have a look at the joystick that you've got in your kit, if you sort of really have a look, you'll notice that the thumbstick part is connected to two trim pots. Now trim pots are just small potentiometers, right? And a potentiometer is just a resistor with a third connection, which we often say is attached to some sort of wiper, and that connection moves and it essentially cuts the resistor in half. So let's have a quick look at this, right? So this guy here and you know what, maybe I should draw it in the more modern notation, which is that a resistor is, a rectangle. Those mean the same thing, right? The rectangle. So here is our potentiometer, and what you would be actually looking at if you were looking at a real potentiometer would be, some sort of circle with a something you can adjust in the middle, like a winder, that you'd attach some sort of knob to, and it would have three legs coming out of it, and these legs correspond to this point here, and this one to this one in the middle. And we often give these numbers, so we might call them sort of 1, 2, and 3. 2 is almost always, in examples that I've seen, the middle leg, so that's helpful, but you can really think of 1 and 3 as being sort of interchangeable. So what this device does, the potentiometer, is it allows you to, if you were measuring between this point here and this point here, using a multimeter set to measure resistance, what you would be able to do is, if this was perfectly in the middle, right, the resistance you measure across here and the resistance that you measure from here to here would be the exact same value. Right, so let's say that this is a 5 kilo ohm resistor. This would be telling you 2.5k, this would be telling you 2.5k, right? As you sort of move this wiper or contact further this way, you've essentially cut the resistor in a different spot. So you might start to see, or you would start to see, less resistance here and more resistance here. And that might look something, I'll just give you some arbitrary values, that might look something like 4k and 1k. And if you wind it all the way to its extreme end, right, where it's not actually touching the resistor at all, it's actually contacting this end, then this might say 0. Like it might have a resistance of very close to 0. Not all potentiometers are built so that you can actually get to a resistance of 0. But if, on some, if you wind this all the way so that it's actually not on the resistor, it's basically just touching this point here, then there is almost no resistance or very little measurable resistance there on that. So what does this mean? Let's wipe this off. And let's start with our middle example. Right? What this means is that if you've got a resistor and you are cutting it through the middle with this contact, and you've got half the resistance here and half the resistance here, if you connect one end to, let's say, 5 volts and one end to ground, and there is no other resistor in this pathway, so this is just a series pathway with one, or you can think of it as 1 or 2 resistors, depending on how you choose to look at it. I sort of think of voltage dividers as almost being, as being 2 resistors. Then what you're going to have is you've got half your voltage dropped across this point and half your voltage dropped across this point. And let's just pretend we've got some little voltmeters in there. So a voltmeter in there and a voltmeter in there. Right? And if you move this third leg, so if you move it up like this, so now we've only got 1K and we've got 4K down here, then you're going to have a much greater voltage drop across this point, because this is a much greater resistance, and a much smaller voltage drop across this point, because that's a much lower resistance. And using Ohm's law, we can actually figure out what the voltage drop is across this half of this resistor and this half of this resistor. So let's do that. The first thing we need to do is we need to write out Ohm's law, right? And the first thing we need to do is we need to solve for current. So we're going to rewrite this equation to try and get current on its own. So we can divide both sides by R, which lets us cancel out these terms, and we can rewrite this equation as current is equal to voltage over resistance. Awesome. So we know that our voltage is 5 volts, and we know that our resistance, in this example, is 5 kilo ohms, or 5,000 ohms. And so that's going to tell us that we have a current of 0.001 amps, or that's 1 milliamp. Right? And I don't know why I'm doing this in red pen. Okay, so now that we figured out this, right, we could figure out what's the voltage drop across this first part, this 1K side of our resistor. So we can write out Ohm's law again, V equals IR. And in this case, we're going to use current, which we just solved, and this resistor here. So our current is 0.001 amps, and our resistance is 1,000. And so our, 1,000 ohms. And so our voltage is 1 volt. So we're seeing 1 volt across this leg right here and this point. And to solve the other side, V equals IR. So that's for this half. That's for this half. So V equals IR, so current is again the same, multiplied by, which is going to give us 4 volts, right? And as we sort of move this leg, because this is a component that you can adjust, you can move it, dynamically in real time. As we move this leg and change these resistances, we change the voltage proportionally, right? So the big takeaway, I guess, is that a voltage divider lets you, divide a voltage. It's one of those very straightforward named things, and that there is a greater voltage drop across the larger resistor, or the greater sort of resistive element in that voltage divider. So as you turn it, you get a varying voltage signal, and you can measure that varying voltage signal, come back to our schematic, between this point here and ground, which is what's happening here at this pin A0. So A0 is measuring the difference, or sorry, the potential difference or the voltage between A0, which is this connected to this leg, and ground. So we're actually measuring as if we had a voltmeter between this leg and ground, and we're measuring that on A0. So as you move that potentiometer, right, that voltage changes, and the Arduino is capable of measuring that voltage and converting it into a value for us. Now, the reason I've got two potentiometers here is because these thumbsticks have an x-axis and a y-axis, or a vertical and a horizontal axis, right? And the way that it does that is it just has two potentiometers built into it. So one you adjust by moving, the thumbstick across one axis, and the other one you adjust or you change by moving it across the other axis. All right, so that is how the input side works, right? Now, the output side, we did another little video on servos, so I'll restate some stuff here, but I might go a little bit faster than I did just this one here. Okay, so a servo, right? So a servo has a connection for a positive, and it has ground, right? These are just connecting the thing to power, and it has an input, right, or a signal wire. And right now this is connected to pin D3, and I've connected that to pin D3 because the servo needs what's called a pulse width modulated signal in order to turn to its position. So a quick refresh, a servo is basically it's a DC motor with a gearbox and a little control board built into it that can measure the angle of the servo and tell the servo to turn to different angles. And normally that's 180 degrees, but with everything, there's servos that do all sorts of different degrees and look like all sorts of different things. But that's what a servo basically is. Now, when we talk about a pulse width modulated signal, right, we're talking about a signal that rapidly turns on and off. Now, if it's at what's called a 0% duty cycle, it means it's off all the time, right? And we can see here, it's at 0 volts with respect to time all the time. If we've got a 25% duty cycle, then it is on for approximately 25% of the time, 50% of the time, 75% of the time, 100% of the time. You get the idea, right? Now, the servo is listening for these different pulses, and for a servo, these different pulses tell it which angle to turn to. And so we'll look a little bit at pulse width modulation, and how to create pulse width modulation in our Arduino. Let's just move this off the screen, if I can. Right, so let's look at actually connecting the circuit and the way in which it is sort of mirroring the schematic. So we've got what we've normally got, which is our Arduino Nano on our breadboard. We've got ground coming from the Arduino and connected to this power rail. So every pin along here is negative. And we've got 5 volts coming from our Arduino to this side. So everything here is at plus 5 volts. Now we've got the servo being powered from this rail. And that means that our Arduino is actually supplying power to the servo. Now, we're using really little servos, so we should be able to get away with that. But this is, far and away my least favorite way of powering anything like a servo or a motor. Because servos and motors and, they're an example of a, not really a low current device. They do have a reasonable current draw, even these little ones. And so this Nano will already be struggling to power this servo, right? It's quite a large current draw for it. But given this is what we've got access to at home, this is going to do just fine, and we probably won't blow up the Nano. Right, and then we've got this signal wire, and the signal wire comes down like this, and it's plugged into pin D3. So if we look at our schematic, cool, so here's our plus 5 volts going to the servo, here's the servo going to ground, here's our signal wire going to D3. Now, let's look at our thumbstick. So the thumbstick, I've represented it as 2 trim pots, or 2 potentiometers, because that's what it is. So both of these trim pots is connected to 5 volts. And so we've got 5 volts coming You know what? I don't know what I was thinking when I did this one. I've actually got this wrong, so it's a good thing that we're having this discussion now. All right, so this one here is currently connected to, I'm not even sure what pin that is because I can't see it. I think it might be V in or something. That's not very good. So this should run up like this and connect to this positive side of our rail, and our negative should come up like this and connect to the negative side like this, or ground. So that's where both these trim pots are getting plus 5 volts and ground. And then these contacts, or these center points that are connected to our trim pots, these come out of our thumbstick at pins called, I think they're called VRX and VRY. On different thumbsticks, they can be called different things. And so those come out and they go into, I think I've got X going into A0 and Y going into A1. That's how I normally plug these in. Now, which pins are which can change. So on your thumbstick, you need to make sure that you're paying attention to which pin is called, VCC, which pin's called ground, which is called VRX, which is called VRY. There's also a button on these little thumbsticks, so you can push them down and close the contacts on a button, which can be really useful as well, but we're not going to use those today. So make sure that you are paying attention to what's going on here, right? Anytime you're working on a breadboard, right, don't just follow it blindly. Look at your different pins, think about where you want them to go, and plug them in accordingly. Right? If you want to have a look at what mine looks like plugged in, and I'll make this available on a document for you. Right, here's my Arduino. You can see there's my 5 volts and there's my ground coming out of the Arduino. We've got positive and ground and the signal wire. They're all going into this terminal for my servo. And here is my thumbstick, and it is plugged into, you can see we've got ground and 5 volts. They're going to this rail. So, 5 volts, ground. And you can see, this is ground. This is 5 volts. And then we've got VRX and VRY, and they're going to A0 and A1. And then we've got the switch. And I've plugged the switch in, I think, to like D10, because maybe I'll use the switch later, but it's not super important for the moment. So pay attention to where things are on different sort of components and make sure you plug them in correctly. All right, we can get rid of that now. Or maybe we can't. No, we can't. All right. Cool. So let's have a look at how we get this actually working. So what have we got? We've got 2 inputs and we've got one output. And being a little bit more specific, these inputs are analog, and the output is, we're going to say that that's analog as well. Maybe we won't. We're just going to say that that's a pulse width modulated output because that makes the most sense, because that's what it is. You'll see why I sort of tripped over myself there and used the word analog in a second. All right, so we've got 2 inputs. So we need to declare that those are, plugged into different places. We've got an output. We need to declare that that's plugged into a different place. We've got a servo. So we need to do all the work to set up a servo. And we've got to do some control, because ultimately what we want to do is control this servo using this thumbstick. So keeping all that in mind, let's open our little new sketch in our Arduino IDE. And remembering that we have all of these great examples in here. So if we go to examples, if we want to control a servo, here are some servo examples. And this one actually is exactly what we're going to do today. But we'll write this out anyway. And what else have we got? We've got examples. We've got analog. We've got analog input examples too. So we have examples of all the code with little links that we can follow that take us to, instructions on how to do all of these things. Right? So keeping in mind that you can and should look at these as you go through. All right. So what have we got? We've got 2 inputs, 1 output. So let's declare our pins for a start. So we will call them, and I'm going to use const int because those do not change. and we are going to give those some sensible names. So let's do the inputs first. So let's call this x-axis, and it is on A0. And it is on A1. And the servo, we actually don't need to declare our pin for the servo just yet, because the way that we do that, if we come over to servo, is we actually tell the servo where it is attached. So, you know what, just for clarity's sake, let's do the inputs first. So we've got these. Now what we would like is we would like some variables to store information coming from these pins. So int, and let's call this xval, and set that as equal to 0. Whoops. And set that as equal to 0 as well. So going back to basics, remember this is an integer. It's got a name, right? That's the name of our variable, and we're just setting it as value 0 to start with, right? We can change that value later on. All right. So now what do we need to do? So let's go over and have a look at our little examples. So what do we got? All right. So we've got a way of reading what's happening on a pin and writing it to a new variable. So if we look at this, right, the way that we would write this would be, what's the name of our variable? So our variable is called xValue. And we want to tell it that xValue is going to be equal or set to whatever we analog read, whatever we see happening, or the Arduino sees happening on x-axis. So that's our, you can think of this is where it's plugged in, but this is the value that it's actually going to store the information in. And this is the command to set xval to x-axis, right? And then let's just put in a little delay of 50 milliseconds. And I'd like to see what's going on this variable. So let's come back up here to void setup. And we'll put in serial begin 9600. Now this is the command to tell the Arduino to talk to the computer at this speed. The reason that we do this is because it lets us do things like print to the serial monitor. So we can write serial, serial print ln. So print ln is just print each value on a new line. And we are going to have a look at x value. Right, and if we check our tools and check that we're using an Arduino Nano, yep, that we got the old bootloader on because that's what works for us. And I've got a couple of ports here. I think I'm on port 3, but we'll see. All right, so we'll hit upload and we'll see what's going on. Oh, it's asked me to save in another window. Yeah, that'll do. All right, so that's done uploading. So what we should be able to do now is go up here to Tools and our serial monitor, which again has opened in another window. And for some reason, I'm not getting anything. And the reason that I'm not getting anything is because I've been using this, I've been using the IDE with a different type of board, which has a different communication rate. So I need to come down here and do this. There we go. So now that they're speaking the same speed, you can see that I've got a value here. And if I move my thumbstick, I change that value. So what's happening here, right, is let's get some of this stuff out of the way. if you think about these potentiometers, right? As I move the thumbstick, it's moving that center contact along the potentiometer. And as I reduce the resistance, or lower the resistance between the sort of contact point and ground, I reduce the voltage. And as I move it the opposite direction, I increase the resistance and increase the voltage drop. And the Arduino is constantly sort of sampling, or it's sampling every 50 milliseconds, what's going on sort of this pin. And it is turning those values between 0 volts and 5 volts into a number between 0 and 1023. And I don't get quite to 1023, and that's just because I can't quite get the resistance across that wiper all the way up to sort of the whole of the resistor. There's other sort of resistive parts of this circuit that means I'm getting very small voltage drops somewhere else. So I'm not measuring sort of a full 5 volts of voltage drop. If it didn't make complete sense, don't stress too much. We can talk about that in class at another time. All right, so that's what's going on there. So let's just move this off to the side. All right, so that is us doing an analog read and getting some data and also having a look at that data. Okay, so from here, we would like to, I guess, control a servo. That'd be really nice. So what we need to do is we need to put the servo library in there. And so if we go tools, include library, and we're going to include the servo library. Now a library is, I think the simplest way I can explain it is, imagine you had a really long-winded piece of code that did a very specific thing. And you would need to write that out every time you wanted to do something. A library is that, but I guess it's sort of running in the background, if you like. And so you can basically write simple commands that are then, interpreted through this library and give you good, useful outputs. And for the servo, what the library does is basically controls the pulse width modulation. So you can control the servo by changing pulse width modulation, but without having to write code that actually, controls or manually, I guess, you controlling the pulses by writing specific code for pulse width modulation. All right, so we're including the servo, and then we need to, similar to declaring our pins, we need to tell the board, the Arduino, that there is a servo attached. So we do that with servo with a capital S, and then we just give it a name. And I'm going to call it Xserv, because I'm imagining that this servo controls some sort of X-axis thing. Right. And then we need to tell it where is the servo plugged in. So we write attach, full stop, and then we write the name of our servo, which in this case is Xserv. And we tell it that that's plugged into, in our case, it's pin 3. Now, if we go back to our serial monitor, we've got all these numbers between 0 and sort of 1022, 1023. Not very useful to us, really, to control a servo, because a servo can only turn between, or these servos can only turn between 0 and 180 degrees. So we need to actually change this thing, xval, right, which is currently taking values between 0 and 1023. We need to change it to something that is a little bit more useful. Those would be values between 0 and 180. So the way that we do that is we use this thing called the map function. Now, if you type in Arduino map function, you will get a whole page that shows you sort of exactly how the map function works. I will take a quick snap of that right now and sort of throw it in here for a second. So this is how the map function works. So this is the command map, and here is your value or your variable. So you put in whatever that variable is. So in our case, that would be, what do we call it? We called that xval, right? So we would write map xval, and then we would put in its original value. So its original values were from 0 to 1000 and let's say 1022, because that's as high as we got a value. And we would say, okay, so these values, I want you to change the 0 to, well, 0 because we want 0 degrees, but I want you to change the high value to 180, right? Because that's the number of degrees that we can move to. And that means that from that point on, this variable, it doesn't show up as being these values, it shows up as being these values here. So you map one set of values of a variable to another set of values of a variable. And so let's put that in. So let's get rid of, or rather, let's just comment out these two bits. And let's put in, xval is equal to map xval. And what did we say? We said we started with a range of 0 to 1022. And we want to change those to a range from 0 to 180. And actually, let's just get rid of these. Let's just uncomment those out for the time being. We'll upload that and then we'll have a look just to check that that has changed. Whoop, what did I do? Okay, I've put in an error there. Hold on. What have I written wrong? All right, it's the other way around. So you put in the variable. Sorry, so just for the servo, you put in the name of the servo. Attach 3. Righto. All right, now let's have a look at our serial monitor. All right, that's looking promising already. So we go from values of 0, 88 in the middle, to 180. All right, very good. So that's done exactly what we want. All right. So now all we need to do is we need to tell the servo to turn to whatever x value is. So let's go. We need to name our servo. So xserv. And then it's just write. And if you put a number in here, that's a way of saying, turn the servo 90 degrees or turn the servo 180 degrees. We've done this before. So now, instead of writing in the actual physical value, we're going to put in xval. And that is going to, as that changes, this command here is going to tell the servo, okay, so turn to whatever x value is. We're going to decrease our delay to 10 milliseconds. And we might as well keep having a look at serial print. All right, so let's upload that one. And now I have some sort of problem with my port, which is annoying. All right, give me a second. All right, so it turned out I just bumped something. All right, so let's have a look at our... All right, so we've got those values there, and let's see if our servo turns. And I don't know if you can hear that in the background, but that is the joystick very confidently moving that servo. Okay, so that's annoying. All right, so now what have we done here? We've only read one axis of the thumbstick, right? We've got two axes. We've got the x-axis and the y-axis. And so what we could do from here is we could, write some code that read the y-axis as well, and we could use that to control something else. Now we could use that to control another servo, and at that stage we are, we have enough equipment and technology and whatnot to make something like this, or there's a whole range of projects that are controlled with servos. Servos are a really, really wonderful tool because they allow really precise control of motion with what is, a relatively low degree of complexity, really, if we compare that to controlling something like a stepper motor. So what I'd like you to do is there'll be a resource sheet with some questions on it, some about the schematics and working out the voltage drop. But I'd also like you to build this circuit and to write this code for it, get it running, and take a small snippet of footage that proves that it's your footage, and just pan up, show me the code, show me the breadboard with the servo and the thumbstick plugged into it working, and that will be, sort of evidence of completion of this task. All right, good luck with that. Get in touch if you need anything.